Alright, everybody in here has done graphing on a coordinate plane. So, since it's so easy, what could I possibly show you that you don't know? Let's find out. First of all, how do we find our way on a graph? First chapter we worked on manipulation and moving things around in an equation. At the beginning of this chapter we worked on solutions to equations, x and y solutions. We talked about those being points that are on a graph, whether or not those points are on the line that the graph, that the equation makes. Today we're going to make sure you understand when we introduce the graph how to find your way. Okay? Let's see here. The first thing you learned about graphing was a number line. Okay? And usually we just said, what do you get when x equals 3? Graph that on a number line. That was the first thing you guys learned. You went from 0 and to the right you went to 3. And then you graphed it. Okay? So this horizontal line is what we call our x-axis when we're talking about the coordinate plane. Alright? Now, that's the first thing. The second thing we're going to talk about and introduce that you've learned is the height. Okay? And we acknowledge that as being your y-axis. So yesterday we also learned that in an ordered pair, x, alphabetically x comes before y. So believe it or not, there are quite a few students in here that struggled with always having x first. They would put y first for some reason. Well, x comes before y alphabetically, comes before y in your coordinate, in your ordered pair. And also, when you find your way on the graph, you need to use the x coordinate first. And then you go up or down based on what is in the y position. Believe it or not, you have quite a few students, even in this class, that struggle with that. Graphing, for some reason, never sunk in. So, example 1. Let's look at, let me erase this and we'll draw bigger graphs. It's easier to see. Example 1. That's x, that's y. We put arrows on it to make sure everybody understands that it goes forever that way, this goes forever down that way. Okay, it's an infinite graph. Alright, now, so yesterday you learned about the coordinate xy. X is always first, y is second. You just learned that the x coordinate is represented on the horizontal axis, just like your number lines that you've learned in the past. Everybody with me so far?
Yeah.
And we also learned that the y coordinate now gives it a height. Okay? Either a negative going down or a positive going up. So, we always start at the origin, which is this point right here. Now that is a point. What is this point on the x-axis?
0.
0. What is it on the y-axis?
0.
Okay, so you all know that's 0, 0. That's the easy part. So, those of you who struggle, let's look at 1, 4. The very first thing you do, like we did with the number line, is where is x equals 1? Here's the number line, x equals 1 is right there. don't put a dot. Because we're not just doing a number line. We now need to go up or down based on whatever y is. If y was 0, then yes, you would put a dot there. Alright? But y is now 4. So from 0, we went over to 1. And y is positive 4. Positive means we go up. So from there we go up. Or you can go over from 4. Wherever those meet, that is where you put your point. You do not need to put dotted lines on your graph. But if that helps you until you finally get it, great. Again, this teaching is really for those who have struggled with graphing before this. All right, now, a little piece of advice for you. When you get into Algebra 2 and you're going to add another dimension to this, I would use dotted lines, because you're going to need it. Anyway, keep that in the back of your mind. So, these are positives on x, right? And these are positive on the y-axis. This is your first quadrant. What?
We did this last year.
Yes, I know you've done this. I'm focusing on the people who really still do not get this. We'll get to some other stuff. A lot of this stuff in the beginning of the book is review for you guys. It's all right. Do you want me to give you all new stuff and that everybody struggle? Or do you want an easy A and we keep going on, building on it? Okay, don't complain. Now, and you weren't complaining, but your face looked like you were complaining, all right? All right, now, this is not like a clock. It is counterclockwise. X's are negative, Y's are positive over here. Y's are positive, X's are negative. So this is quadrant 2. In quadrant 1, everything's positive. Quadrant 3 is down here, and X's again are on the negative side, and the Y's are now on the negative side. And the fourth quadrant, except flip. X's are positive, and the Y's are negative. Alright, that's all review. Can you graph? What quadrant, let's do this. First of all, what point is that? Raise your hand. What is that coordinate? I want somebody who thought they didn't know how to do graphing to raise their hand and tell me. Yeah. This is -3 on the y-axis. Now what is it as a coordinate? This is what we call a coordinate right here. So when I ask for a coordinate, or your book asks for a coordinate, you got to answer it like that. Yeah.
0, -3.
Yeah. According to this point hits the x-axis at 0. So x is 0 and y is -3. Okay. Now, what quadrant is that point in? Now I want everybody who knows the answer to raise their hand, since you all thought this was easy.
Right.
Do you want
No.
to? Yes, Clay.
3 and 4.
Okay. That's wrong. Now, I don't like that question because I think it's ridiculous that they ask it, but they do ask you that question and typically put it on an axis. It's not in any of the quadrants. It's on the y-axis, and that would be your answer. So I did that because you will be asked, I don't know about this book, but I've seen it on tests. It was in the last book we used. It's kind of a trick question. They're implying that it is in a quadrant, which it obviously is not based on their answer. Got it? All right, one last thing. Since you're all so smart and you remember everything.
Yeah.
What's that?
I thought we were stupid.
That's what you thought, Mr. Stu.
I don't know what you're talking about. Find the distance between 2 points. So I know you've all had this as well. Basically this lesson is all reviews. So what I want you to do now is I want everybody, without looking in the book, to write down the distance formula. I'll look at it. Okay.
It's circle.
All right, did you get it? Without looking?
It's circle.
It's rec circle.
It's circle.
All right, now I want to teach you why the distance formula is the distance formula. Okay? Instead of somebody just giving it to you and telling you to memorize it, there's a reason that it works. Do you all know what this is?
Pythagorean theorem.
Oh, good, you can memorize things well. Good, not every time you can't memorize. All right, well, it's a triangle, right? It has to be a right triangle. Well, here's a coordinate plane. This is a right triangle.
Yep.
So, 1, 2, 3, 1, 2, 3, 4. We'll make it easy. So this is a right triangle. I want to know what C is. If this is A and that's B, I want everybody to figure this out. So what is A, first of all?
6.
2.
3.
3.
What's B?
Times 2.
Okay, it's 4.
4. Okay, so A is 3, and remember when we substitute, you put parentheses around it, that's not 3 times 2, people. 3 squared. What's 3 squared?
9.
9. Okay, what's 4 squared?
16.
Alright, so you have 9 plus 16, so that's 25, right? 9 plus 16? Yes?
Yeah.
Okay, so what's C, not C squared?
C is 25.
C squared is 25, what's C? 5. Right?
Yes.
Okay, so you're telling me the distance from this point to this point is 5.
Yep.
Wonderful. Tell me what this coordinate is right there.
What did you say?
This coordinate right here.
0, 4.
So on the x-axis, we need the x value first, right? That's 0. On the y-axis, it's 4. This point right here, what is that? On the x-axis, it's 3. On the y-axis, it's 0. All right, we're going to find the distance between those 2 points. You're telling me that that's 5.
No.
Right?
Yes.
All right. Here's the distance formula. Let me explain. You take the difference in your x's and you square them. Then you add the distance between your y's, differences, and you square that. And then you got to take the square root of all that. Watch. You squared A, right?
Yep.
A was 3. How did you come up with 3? Didn't you take the distance from 0 to 3?
Yep.
Well, isn't that 3 minus 0?
Yeah.
And how'd you find B? You said it was 4. How'd you know it was 4? It's the distance from this point to that point. 0 and 4. 4 minus 0. What'd you do with those values? You squared them first, didn't you?
Yeah.
And we're squaring them here. And then we added them together, right? Pythagorean theorem? We added it together. This is A squared plus B squared. Where did the square root come from? Anytime you want to get rid of a square, take the square root. What's the square root of C squared? C. What's the square root of 25? B is really what C is, okay, in the Pythagorean theorem. The distance formula is nothing more than the Pythagorean theorem, solved for C, not C squared. Okay? So if you just want to memorize it, take the differences in your x values, the differences in your y values, you square each of those, add them together, and then take the square root. But the distance formula came from the Pythagorean theorem. Can you do that, or you want to see another example? All right, here it is. -2, 1. Everybody's going to do this. And 4, -3. You got 30 seconds. Quickly, plug it into the formula. It doesn't matter what order of x's and y's you do, like it does on your slope. The order doesn't matter.
Okay.
20 seconds. Right faster. While you're writing, I'll set up the first step. You should already have that done, plugging it in. And I'll just do everything different, in a different order, just to show you that it works. Subtracted my x's. 4 minus, or -2 minus 4. And then I subtracted my y's, and I went this direction. When you do your slope, you can't do that. It doesn't matter here because we're going to square the values. Alright? -2 minus 4 is -6. -3 minus 1 is -4. It doesn't matter if it's positive or negative because when you square it, you're going to get a positive anyway, right? So if you took 4 minus a -2, you got a positive 6. But you square it, you still get positive 36. You square this, you still get positive 36. So the order that you did that does not matter because you're squaring the value. So this is 36. This is 16. 36 and 16 is 52. Handy dandy calculator, what do you get? Square root of 52. Yeah.
Oh, it's square root.
7.21110.
Yeah.
255. 1.
7.2 what?
10.
Oh my gosh.
Alright. You can use approximation symbols. If you round it, I want you to use that right there to just show that you rounded. If the book tells you to round it to the nearest tenth, you better have it rounded to the correct position. This is how I'd round this to the nearest tenth. I'd underline the position I'm rounding to, that's the tenths. I look to the number to the right. Since that's less than 5, the 2 stays the same. So that would be my answer, okay? Any questions? No? Assignment. Should you choose to do it? Page 56, 19 to 36. I tell you what, since it's a long, awesome weekend, we'll do 20 to 36 evens.
Oh,
Yes.
You did have other problems, but we'll not do that. All right, get to work. If you can't be quiet, you're getting all of them.